Hi everyone, myself Mrs.T.ARUNDHATIE, Assistant Professor of Geology, Department of Geology from A.D.M. College for Women, Nagapattinam. Today we are going to see about the mass movement. What is mass movement? Its introduction, causes of mass movement, its classification, effects and the preventive measures and warnings for the mass movement. First, what is mass movement? Mass movements are also called mass wasting. It is the downslope movement of regolith. Regolith means it is a loose, uncemented mixture of soil and rock particles that cover the earth's surface. It is regolith. So, it is the downslope movement of regolith by the force of gravity without the aid of transporting medium such as water, ice or wind. Water plays a major role in mass movements. It is a part of continuum of erosional process between weathering and steam support. Mass movement causes regolith and the rock to move downslope, where sooner or later the loose particles will be picked up by another transporting agent and eventually moved to a site of deposition such as an ocean basin or lake bed. Mass movement processes are occurring continuously on all slopes. Some act very slowly, others occur very suddenly, often with the disastrous results. These are it is the introduction of mass movement or mass wasting. Then causes of mass movement. Triggers for mass wasting can be divided into passive and activating causes. Causes of mass movement, it is majorly classified into passive and activating causes. Passive causes include rock and soil lithology. It is unconsolidated or weak debris which are more susceptible to mass wasting, or as materials that lose cohesion when wetted. In stratigraphy, such as thinly bedded rock or alternating beds of weak and strong or impermeable or permeable rock lithologies. Fault or other geological structures that weaken the rock, it is also the cause for mass movement. Then topography. The topography such as steep slopes or cliffs also causes the mass wasting because the cliffs are the edges of rocks. Climate. Climate with a large temperature swings, frequent freezing and thawing or abundant rainfall. Then lack of vegetation. These are the passive causes for mass wasting. Then activating causes, which include undercutting of the slope by excavation or erosion, increased overburden from structures, increased soil moisture and earthquakes. These are the activating causes for mass wasting. Then the natural factors, which include slope steepness and the angle of repose. Every type of sediment or rock has a maximum stable angle. It is called the angle of repose. If a slope is steeper than its angle of repose, it is unstable and prone to failure. The steeper slope, the greater the downslope gravitational force, increasing the likelihood of mass wasting. Then water saturation. It is also the natural factor. It is causing mass wasting. Water saturation. Water is one of the most critical factors influencing mass wasting. Its effects depend upon the amount present. Then the water saturation also includes the decreased friction, increased weight, freeze-thaw cycles. Decreased friction, it means excess water fills the pore spaces between the sediment grains, pushing them apart and eliminating the frictional contact that holds the slope together. This turns the material into a slurry that can flow easily. Increased weight. Water is heavier than air, so a water-saturated slope has a greater overall weight. The added weight increases the gravitational driving force, making slope failure more likely. Freeze-thaw cycles. In cold climates, water in the rock cracks and soil pores freezes and expands, widening the cracks. It causes the rock to break easily. When the ice thaws, the material shifts downwards due to gravity. a process that can lead to soil creep over time. Then the removal of vegetation is also a natural factor which causes mass wasting. Removal of vegetation includes it means the roots from plants and trees bind the soil and sediment together, anchoring the material and increasing the slope shear strength. The removal of this vegetation by natural events like wildfire or human activities like logging destabilizes the slope and increases the risk of mass wasting, especially during heavy rainfall. Then weak slope material. Certain types of geological material are more susceptible to mass wasting, which includes the layers of weak sedimentary rock such as shale and clay. These are the common culprits when wet clay becomes the slick and reduces the friction, providing a failure plane for material to slide on. Then the areas with unconsolidated or deeply weathered material are independently it is very less stable. Then earthquakes and seismic activity. It includes the ground shaking from an earthquake can violently disrupt a slope, dramatically reducing its internal friction and triggering landslides, rockfalls, or debris avalanches. Then volcanic eruption. Volcanic eruption is also a major cause for mass wasting or mass movement. Volcanoes can cause mass wasting in several ways. Eruptions can trigger debris avalanches and landslides on unstable slopes. Hot volcanic material can melt snow and ice, creating fast-moving destructive mud flows known as lahars. Weathering. Over time, both chemical and physical weathering process break down and weaken a slope's material, increasing its susceptibility to mass wasting. Then human-induced factors, which include undercutting a slope and overloading a slope. Undercutting a slope, which is the construction activities like building, roads, or leveling lots can oversteepen a slope by removing the supporting material from its base. Natural processes like river and coastal erosion can also cause undercutting. Then overloading a slope. Placing additional weight on the slope, such as from construction projects and land clearing or the placement of fill, can increase the downslope force and lead to slope failure. These are the human-induced factors which causes mass wasting. Then we are going to see about the classification of mass movement. In geology, mass movement types are categorized primarily by the speed and manner of material movement. Speed and manner of material movement, which includes falls, slides, flows, and creep. Falls means it's a rapid and free falling. The rocks are rapid and free falling. Slides, it means rapid to slow movement along a defined surface. Flows, fast to slow movement of water-rich debris. In water-rich debris only the flows will happen easily. Creep, very slow, imperceptible soil or rock movement. These are the specific, these are the classification of mass movement. Then the specific examples which include rock falls, rotational and translational slides, mud flows and earth flows, and soil and rock creep. These are the examples which comes under the classification of mass movement. This is the diagram which represents the types of mass movement. It is based on the fast speed of movement and the slow movement. These are the examples which includes the debris flow, solid flexion, slump, earth flow, mud flow, debris flow, a rotational rock slide, rock fall, rock slide. These are the examples and this picture represents the types of mass movement. Types of mass movement. Then the mass movement classification is based upon two, which is one is rapid mass movement and another one is slow mass movement. Rapid mass movement, it includes falls, slides, slump and a rock slide. Falls means the free falling movement of individual rock or whole debris fragments down a steep slope. Then slides, the downslope movement of a coherent block of soil, rock or debris against a distinct surface or plane. Slump, a type of slide where material moves along a curved surface forming a crescent-shaped scar. Then rock slide, the rapid movement of large disconnected rocks downslope. These are the rapid mass movements. And this picture shows the rock fall and mudslide, which is the type of mass movement. This first one represents the rock fall and the second one represents the mudslide. Mudslide is happening due to loosening of debris and the loosening of rock materials. Then flows which include mud flow, debris flow and earth flow. This comes under the flows, which is a type of mass movement. Flows, mass movement where earth material behaves like a fluid due to high water content and often mixed with other materials. This is flow. Then mud flow, a rapid flow of water saturated soil, debris and mud often occurring after heavy rainfall. Then debris flow, similar to a mud flow but with a higher concentration of coarser, larger materials like rocks and boulders. Boulders are small than rocks. Earth flow, the movement of water saturated, fine grained materials often on low angle slopes. These comes under the flows. Then this picture represents the flows. Flows means when it happens means when the material behaves as a fluid, then only it will comes under flow. The first picture represents the earth flow and the second one is mud flow or debris flow. Then creep. Creep comes under the slow moving mass movement, whereas rock slide and the falls comes under the rapid moving mass movement. The creep comes under slow moving mass movement. Creep means the gradual, imperceptible downhill movement of soil or rock debris over long periods. Then solifluction. It also comes under the slow movement process. If solifluction is a form of creep where saturated soil or fine rock debris flows slowly downslope due to excessive moisture. Then this is the creep. This is where the soil and surface material that slowly moves down to a slope. This picture represents the creep. Then this picture fully represents the types of mass movement which include fall, flow, slide, rock slide, etc. based on the nature of erosion. Then the effects of mass movement. What are the effects after the mass movement? Effects on landforms and the topography. The first one, landform creation and the destruction, which includes the mass movement shapes the earth's surface by creating new landforms and reshaping the existing ones. Then mountain and valley modification. They affect the morphology of mountain and valley systems, impacting the landscapes on continents and ocean floors. Then the deposition. Deposition also causes the effect on landforms. When the materials like soil and creep, rock debris are transported downhill and deposited, it creates a new landform such as debris fans and accumulation zones. Then the effects on environment and ecosystem, which includes soil degradation, vegetation loss, water system changes. First, soil degradation. This is a process can wash away fertile topsoil, reducing the land productivity and leading to soil degradation. Then vegetation loss. Mass movements often remove the vegetation cover, which is essential for soil stability, further contributing to land degradation. When the first layer of vegetation cover is removed, then the soil stability, everything gone, and the fertile of topsoil also losses. Then water system changes. They can alter river and streams characteristics as well as groundwater flow by adding sediment and debris. Then socio-economic impacts, which include infrastructure damage and property and life loss. Infrastructure damage. The mass movements can cause widespread destruction to roads, buildings and other infrastructure. Then property and life loss. Devastating events like landslides, mud flows and rockfalls can result in significant property, damage and loss of life. These are all the socio-economic impacts. Then the factors affecting mass wasting, which include water on the slope. On the slope, when the water intrudes on the slope, then the rock gets the soil gets loosened and it gets erosion, which causes the rocks to get the rock slide. These are the factors affecting mass wasting. Then preventive measures. Preventive measures for mass movement, which includes slope management, such as reducing the slope angle, using retaining walls and terracing to stabilize the slopes. Vegetation planting, it means afforestation. It uses plant roots to bind the soil and drain water. Drainage control diverts water to prevent soil saturation, while the engineering solutions like rock netting, gabions, and early warning systems, it can prevent the rockfalls and alert communities. Finally, land use planning and avoidance of high-risk areas are crucial to prevent building on unstable slopes. Then planning and monitoring. Land use planning means developing the plans that ban the construction in vulnerable zones to prevent mass movement. Then hazard mapping. It identifying and mapping the areas prone to mass movement to inform the land use decisions. Then yearly warning system, implementing the systems to monitor slopes and issue alerts before a mass movement event occurs. Then relocation, moving the communities or infrastructure out of high risk zones. Then the public awareness, it also the preventive measures of mass movement. Then slope modification, which includes terracing, slope leveling and reduced angle. Terracing means the shaping the slopes into steps to make them more stable. Slope leveling, it reducing the overall incline of a slope. Reduce the angle, lowering the angle of steep slopes to lessen the force of gravity. Then barriers and walls to prevent the rock slide mass movement, which includes retaining walls, gabions, and catchment dams. Retaining wall, it means the building sturdy walls to support unstable slopes and prevent erosion. Then gabions, wire mesh cages filled with rock used to hold soil in place. Then catchment dams, structures designed to contain debris flows. Then the reinforcement and the protection for mass movement, which include rock bolt and cables. Steel bolts and cables driven into rock to anchor it. Then the rock netting and the screens. This is the installing the wire mesh to prevent the rock fall. Then concrete spray. It covers the steep slopes with concrete to prevent the erosion. These are all the reinforcement and protection for mass movement. Then vegetation and water management. Afforestation. Planting trees and grass to bind the soil with their roots. It prevents the rock slide, everything. Then improved drainage. Diverting the water away from slopes through the ditches and the pipes to reduce the saturation and the soil weight. Then evapotranspiration. Vegetation helps remove the water from soil, reducing its weight. This picture shows the preventing mass movement, which is these actions can reduce the mass movement hazard, slowing or eliminating the undercutting, which increases the stability of the rock slides. Then removing agents of erosion at the base of slope, reducing the effect of agent of erosion. This is the preventive measures of mass movement. Then warnings. What are the yearly warnings we get from nature and yearly warnings from other sides? Springs and seeps are saturated ground in areas that have not typically been wet before. Then new cracks or unusual bulges in ground, street pavements or sidewalks. Then the soil moving away from the foundation, and ancillary structures such as decks and patios tilting or moving relative to the main house. Then tilting or cracking of concrete floors and foundations, broken water lines and other underground utilities, leaning telephone poles, trees, retaining walls or fences, offset fence lines, sunken or dropped roadbeds, rapid increase in creek water levels, possibly accompanied by increased turbidity, which is the soil content. Sudden decrease in creek water levels through the rain is still falling or just recently stopped. Sticking doors and windows and visible open spaces indicating the jams and frames out of slump. A faint rumbling sound that increases in volume is noticeable as the landslide nears. Then unusual sounds such as trees cracking or boulders knocking together, then it might indicate the moving of debris. Then what are the recent mass movement which happened in the earth? The recent mass movement event include a deadly landslide near Vaishno Devi Shrine on August 26, 2025 that killed at least 34 people and a massive landslide on National Highway 5 in Himachal Pradesh on September 6, 2025, which crashed the rocks and rubble into Naphtha Dam. Then in 2024, a landslide in Papua New Guinea buried a village, potentially killing 670 people, and deadly mudslides hit the Kenya after the weeks of heavy rain. These are the recent events of mass movement. Then here's a summary of recent significant events, which includes Vaishno Devi landslide, which happened in August 26, 2025. Then Himachal Pradesh highway landslide, which is on September 6, 2025, Papua New Guinea landslide 2024, then Kenya mudslide. It happened 2024. It is because the weekends of torrential rain to deadly mudslides in Kenya. Then Wayanad landslide 2024. What happened means a significant loss of life and property damage occurred due to the landslide in Wayanad district. Thank you.